They told us we understood the sun. That we had mapped its storms, modeled its cycles, and captured its fury through telescopes from a safe distance. But what if everything we thought we knew was only the surface of a deeper, stranger truth? A truth now staring back at us from the final images of a spacecraft that dared to do the unthinkable, touch the sun. This is not just another space mission. This is humanity sending a messenger into the very heart of fire. And what it saw changes everything. In this video, we reveal what NASA's Parker Solar Probe just confirmed, and why its final images may rewrite everything we thought we knew about our star. If you believe the sun is just a giant ball of burning gas, you're in for a shock. The Parker Solar Probe wasn't supposed to exist. Not with today's technology. Not with human limitations. But the mission was driven by a question first asked in the 1950s by physicist Eugene Parker. Could the sun be hurling invisible particles across the solar system? The probe was launched to dive closer to the sun than any human-made object before. A technological gamble, it would fly directly into regions where spacecraft simply weren't meant to survive. At its closest pass, Parker came within just 5 solar diameters of the sun's surface, unimaginably close by cosmic standards. Accelerating under the sun's powerful gravity, it reached a record-shattering speed of 430,000 miles per hour, fast enough to cross the United States in just 20 seconds. But speed wasn't the mission's real goal. Discovery was. With every moment inside the sun's corona, the outer atmosphere visible only during a total solar eclipse, Parker recorded data that confirmed Parker's theory of the solar wind, and uncovered something far more perplexing. We've been told the sun is a predictable fusion reactor. That its surface is the hottest point, and its behavior can be charted with mathematical certainty. But the probe found something that defied physical logic. The corona was millions of degrees hotter than the surface, even though it was composed of an incredibly thin, ghost-like gas. How could something so faint be so much hotter than the roaring inferno beneath it? Thermodynamics says it shouldn't be possible. It's as if an unseen force is injecting energy into this ghostly layer, in a way we still don't understand. And these particles don't just stay near the sun. They escape, traveling vast distances, eventually colliding with Earth. The solar wind wasn't just real, it was far more violent and erratic than imagined. And every new solar cycle could bring the kind of storms that disrupt satellites, knock out power grids, and even threaten national security. Then there was the problem of survival. How do you get close to something that could melt steel in seconds without melting yourself? The answer: carbon. Not a futuristic alloy, but a carbon composite shield, the material with the highest known melting point on the periodic table. Even that wasn't enough. The shield had to be kept at a precise angle at all times to protect the instruments from the sun's energy. Because the danger wasn't just heat, it was radiation. Radiation that could shred electronics, erase data, and destroy the mission in a microsecond. Hidden behind that shield, Parker's instruments measured magnetic fields, particle flows, and energy signatures, revealing disturbing fluctuations that no existing solar model could explain. Something is happening beneath the sun's surface, something that could rewrite the rules of astrophysics. On one of its closest passes, Parker sent back images unlike anything NASA had expected. Twisting magnetic filaments. Energy bursts with no known origin. And most unsettling, structured patterns in the solar wind. Not random motion, but something organized. It reminded scientists of algorithms. Of self-regulating systems. Of code. Could the sun, in its most extreme regions, be behaving like something alive? NASA has made no claims of artificiality, but the silence surrounding these findings only deepens the mystery. And then there's the memory card on board, carrying a photograph of Eugene Parker, the names of over 1 million people, and the original 1958 paper no one believed at the time. Oddly, the card was not fully shielded. It survived the sun's rage, not damaged, but changed. Scientists have noticed subtle, unexplained shifts in its electromagnetic alignment. Was this just physics, or something else? In one of the final data bursts, sensors recorded something NASA insiders now call the eye. For 48 seconds, the solar wind redirected itself, not randomly, but in a way that appeared to target the probe. Then it stopped, as suddenly as it began. If the sun can, in some sense, look back at us, then we have crossed a line we never even knew existed. A threshold where human curiosity brushes against something far older, far more powerful, and far less understood than our species has ever encountered. The Parker Solar Probe's mission was bold from the start, to dive into the most hostile environment in our solar system and live to tell the tale. But what it brought back is rewriting everything. The sun is not the silent, predictable furnace we thought it was. It is alive with complexity, changing in ways that defy the models. Within its corona, Parker detected heat that should be impossible. It recorded pulses and oscillations that seem to repeat, not randomly, but with a precision that feels almost intentional. Some scientists describe these as magnetic waves, or plasma patterns. But the truth is, no one can fully explain them. The deeper Parker flies, the stranger the data becomes. The solar wind seems to surge in ways that suggest a kind of rhythm, like breath, like thought. Storms that should be chaotic align into unexpected order. Bursts of energy arrive not with noise, but with eerie timing, as if answering something. Even more unsettling, Parker's instruments have detected fluctuations in magnetic fields that echo frequencies found in human-made communication systems. A coincidence so precise that it has divided the scientific community. Some argue it's a natural resonance, a quirk of physics. Others whisper that it could be a form of signaling, not aimed at us, but perhaps at something else in the void. And yet, this is only the beginning. Each time Parker swings by, it inches closer, now brushing against the sun's outer atmosphere, a place where physics bends and familiar rules break. Soon, it will go deeper than any probe, touching the point where light, magnetism, and gravity weave together in ways we cannot yet imagine. There are regions inside the sun's influence where time itself may stretch or fold, where particles follow paths that seem less like randomness and more like choreography. The question that no one dares ask aloud is this: what happens if the sun notices? What if those pulses we've been recording are not just energy, but communication? What if the closer we get, the more it begins to respond, not as an object, but as an intelligence? Because if the sun is not just a star, then our entire understanding of life in the universe changes. Maybe stars are not passive. Maybe they are ancient engines of awareness, scattered across the cosmos, watching, waiting. And if that is true, then we have been surrounded by consciousness since the beginning, and never recognized it. It would mean that every sunrise, every ray of light that has ever touched Earth, has been more than just heat and energy. It has been contact. Subtle, patient, unspoken contact. Perhaps the sun has been shaping life not only through warmth, but through guidance, an invisible hand we never knew was there. This is no longer just a mission of science. It is an encounter. A slow, careful approach toward something that has been burning for billions of years, and yet may be far from mindless. The Parker Solar Probe may be showing us not just the mechanics of the sun, but its mind. And if that's the case, then one day soon, humanity might face a moment we are not ready for, the day the sun answers back. When that day comes, the question will not be what we can learn from the sun, but what it has already learned about us. If that moment arrives, it will not be like any first contact we have imagined. It will not be an alien ship in the sky or a signal from a distant world. It will be a truth dawning in our own star, the realization that the source of our life has been aware of us all along. And perhaps, just perhaps, it has been waiting for us to find